Hey gang, welcome back to another video. Now as a lifelong haunter, I know the challenges many of us face when it comes to lighting. So in this video marathon, I've combined 10 of my best tip and build videos to help improve the lighting in your haunt. So let's get to it. Now I'm often asked, how do I improve my haunt lighting without breaking the bank to do it? And while there's no silver bullet approach to this, there are a few things that you can do with a limited number of fixtures that will definitely improve the overall quality of your lighting. So in this Haunt Lighting 101, I'll show you two of my favorites. So let's get to it. If you've watched any of my videos on LED lighting, then these two DIY options will look familiar to you. The one thing I haven't discussed is our use of floodlights, more specifically these Bluetooth-enabled RGB LED floodlights. Because they're Bluetooth-enabled, I can change the color as well as brightness and saturation from an app to really help dial in just the right look for our display. This is an absolute must and makes adjusting your lighting very easy. The other thing I really like about these particular floodlights is that they come with diffused glass. This helps to create more even light without any hot spots, so it makes it a bit more difficult to tell exactly where your light source is coming from. Okay, enough about the lights, let's talk about how to get the most out of them. I've set up a small section of our cemetery to help with this demonstration. This is more or less how our haunt is set up. Multiple tombstones and monuments in staggered rows to make them easier to see. This is also done to create layers of shadows when they're lit from the front. I've taken two 25-watt floodlights and placed them in opposing corners of the yard, rotated at 45 degrees toward the middle of the display. Let's power them on and see how we've done. Now that's starting to look like something. Because the floodlights are low to the ground, the tombstones are uplit, creating shadows, texture, and height that adds more interest to the display. Changing the position and height of your floodlights will alter these shadows, so don't be afraid to do a bit of experimenting until you're happy with how it looks. I should also mention that these lights are only at 50% brightness. Having the ability to control the amount of light in your scene or display can make all the difference. Too much light and the display looks cartoonish. Not enough light and it becomes impossible to see the details. So being able to adjust brightness can be a huge factor in the overall quality of the light in your haunt. If you had limited lighting, you could stop here. But for our display, we like to introduce accent lighting to help bring out more of the details. This is often accomplished through the use of LED candles. I'll start with a few candles as seen in the foreground and background of this example. These practical lights are not exactly bright enough to adequately light our props, but we can resolve that with a bit of motivated lighting. In short, motivated lighting is the use of an unseen light source that can be attributed to a natural or practical light source within your scene. In this case, the practical light source is the candle, and the motivated light is the added glow created by a hidden spotlight. This use of motivated lighting is a great way to introduce more light to your scene without having to explain where it's coming from. That said, you'll notice there's a secondary orange light that's cast across the fallen bust in the foreground. This is done just to bring attention to the bust, but it's not considered motivated lighting, since there's no real reason for it. But because it's an interesting piece that's in the shadow of a tombstone, I decided to accentuate it anyhow. It also helped to make the smaller tombstone in the center of the display more visible. I guess what I'm saying is that sometimes you have to break the rules. Or maybe just add in a few more candles to make it all make sense. Now back in 2013, I posted a video here of a plug-and-play LED lighting system that I had come up with. Now some of you may have seen this video and some maybe not. So just so we're all on the same page, let's roll that archival footage. Hey everybody, just wanted to do a quick little video here to show sort of a new system that I developed that is basically a plug-and-play style LED spot. So here's sort of the body of it. The LED is already buried down inside the nozzle, and it's connected with an RCA connection. So basically just plug it in there, take the other end, plug it into power brick, and there it goes. And so the terminal is basically, it's a series of RCA plugs, and they're all wired together on the back, reds with reds, blacks with blacks, and then they are connected to a 12-volt regulated power supply with 5 amps, and that's that. Now, while this system's done really well for us all these years, there is no week that goes by that I don't get a question asking where to find the parts and how do I deal with weatherproofing. So in this video, I'm going to tackle answering both of those questions by creating a brand new lighting system that I think should stand the test of time. So let's get to it. Before we jump in, let's start with the parts needed for this build. I have a few female 2-pin 24-gauge waterproof IP65 cables, a waterproof gang box with strain relief fittings, a 12-volt 5-amp power supply, and a barrel connector adapter. The first thing we'll need to do is to prep our 2-pin cables. I'll use my wire strippers to remove about an inch from the end of these cables, and then we'll use a lighter to soften the wire's protective coating before removing it. Because these wires are so thin, I find that it's easier to use this method than to try and use my wire strippers. Now, it should go without saying, but be sure to use caution when working with fire and electrical. Once I have all of my cables prepped, it's time to thread them through the strain relief and then twist all of the similar wires together. Then I can feed them into the gang box. As you can see, this is a tight fit, and I was only able to get 4 cables through the strain relief. You may be able to find a larger fitting if you want more lines coming from your power supply. The next step is to prep and install the barrel connector inside the gang box and join the wires using a few wire nuts. I decided to go with this approach to have the option to salvage the fully intact power supply should I need it for a future project. If that's not a concern for you, remove the barrel adapter and 2 wires, then clip off the barrel connector from the power supply and wire it directly to the 2-pin cables. The last thing to do is to thread the end of our power supply through the fitting, plug it into the adapter, tighten the strain relief, and close up the box. Oh, and add a sticker too. And here's the finished power box. 4 waterproof cables out, plus the box I chose has mounting points to keep it secure. Now let's talk about cable runs and adapters. You can get a variety of lengths of 2-pin cables to fit your setup, and as you can see, connecting them is pretty simple. It's not as fast as the RCA connector version, but these won't rust out over time either. There's also Y adapters as well as these T connectors, which you can assemble in whatever configuration you need using the 2 small terminals inside of each leg. Since our haunt is typically the same layout every year, I'll be adding these T connectors to align with each of our tombstones, essentially connecting them together like this. This setup will allow me to have 2 outlets for each tombstone, one for an LED spotlight and the other for an LED candle. And if I need more outlets, I can add in an additional splitter. So there you have it. I've solved for all the problems that I've noticed over years of using this system by swapping out some of the parts to things that are a bit more durable and designed for outdoor use. Now, if you're anything like me, you use a bunch of battery-powered tea lights in your haunt to light the insides of your foam jack-o'-lanterns. And if you're really anything like me, you've forgotten to turn them off at the end of the night, resulting in a bunch of dead tea lights. Well, I finally reached my breaking point this year, and I'm going to solve this problem once and for all by wiring up our jack-o'-lanterns to work on our 12-volt lighting system. so let's get to it. Before I get into the build, let's take a look at everything we'll need to handle the conversion, starting with these 12-volt Eagle Eye LED bulbs. And since I want them to work on my 12-volt setup, I'll need a male RCA jack to plug them in with, along with some mounting hardware, a 1/2-inch electrical box adapter, and lastly this 4-inch round plastic cover. This cover unfortunately has some weather stripping on the back, but was the cheapest option, so I'll need to remove it before I can proceed with the assembly. Now that I've got a blank canvas to work on, let's start with the build. Because I want the pumpkins to sit flat, I'll need to run the cord out of the back, but that also means I'll need to create a notch on this fitting for it to pass through. So I grabbed my rotary tool and a small sanding drum and got to making a notch. And after a little bit of cleanup, I can set it aside and move on to the LED assembly. These Eagle Eye bulbs are waterproof, but are a bit too tall for the adapter. So I'll add on this washer and a second nut, which will allow me to adjust the height of the bulb within the adapter and prevent the cord from getting kinked as it makes its way through the notch in the back. Now that I know the height works, I can apply some CA glue to the top of the adapter and glue the pieces together. The next part of the build is to create a platform for our light to get mounted to. This also gives me a surface for gluing it to my pumpkins. And once again, I grab my CA glue and this time we'll apply it to the bottom of the adapter and we'll center it on the 4-inch cover plate. And just like that, we've got our finished light assembly. It's essentially the same type of plate you'd find in the store-bought pumpkins, but now you can use it with your own custom jack-o'-lanterns or any other prop that is internally lit. And speaking of custom jack-o'-lanterns, here's one of ours that's seen better days but still finds its way into our haunt every year. And because of that, it'll need a small hole drilled into the lower back so that I can pass through the LED cord and still have it sit flat. So I flipped it over and found a drill bit that's slightly larger than the cord and got to drilling. Before I permanently install the light, I'm going to black it out so that it's less noticeable once it's in place. So I masked off the bulb with some painter's tape and got down to spray painting it, and then set it aside to dry. While I waited, I figured it would be good form to hide the bulb with a fake candle cover, so I grabbed some 2-inch ABS pipe and added some hot glue drips. I have a video dedicated to making fake candles, and I'll leave a link to it in the video description if you want to make some for yourself. Since the likelihood of these candles being seen from the back is pretty slim, I just added drips to the front half and then a bead of glue along the top to finish it off. After some glue cool down and a bit of white spray paint, I was able to then glue the tiny candle to the platform with some more CA glue, and now I can shift my attention to the wiring portion of this build. The first thing to do is thread the cord through the back of the pumpkin, and once that's done, I can disassemble the RCA jack and thread the cover onto the LED cord. With that out of the way, it's time to solder my wires. I'll apply solder to the terminals and the wires, although these wires came pre-soldered, and then I can join the two by applying the soldering iron to the terminal, which will reheat the solder and bond the two parts together as it rapidly cools. The red wire to the short terminal and the black wire to the long terminal. I'll repeat this step for the other wire, and then I can screw the cover back into place, test my connections to make sure that the light works, and move on to installation. The last thing to do on this build is to permanently install the light. So I mixed up some 5-minute epoxy and applied it to the cover plate, and then set the plate into position in the opening of my jack-o'-lantern. I found out later that CA glue would have also worked for this step, plus the bond is a lot quicker. And once the epoxy had cured and everything was securely in place, it was time to plug it in. Once it's placed in our haunt, it'll be connected to a small flicker circuit to help give it a more candle-like glow. But for now, I just need to wait for sundown. Now I have to come clean about something. Our haunt has a lot of extension cords. With every new technique or device that I add to it, it always seems to come with a requirement of more power. But thanks to this video's sponsor, I'm going to cut down on a huge chunk of that. But before we can do that, we better get the haunt set up. So let's get to it. The first thing I always bring out are the columns. They weigh the most, but are also the brains of the whole operation. So it's important that they're in place and ready to keep out trespassers who want to visit the cemetery after hours. Once those are in place, I get to bringing out all of the tombstones and monuments. They're placed roughly where I want them, but won't be set into their final position until a bit later. Next up is the Hallowed Haunting Grounds tombstone and fence, which always takes me a minute to figure out which pieces go where. Then it's time for the gates, and of course, a lock. Now we can talk lighting. Ustellar, the sponsor of this week's video, sent me this 6-pack of RGB LED lights that can be individually controlled by their smartphone app. But what really caught my eye is that they're all connected. So I don't need to run 6 extension cords, which, when you don't have a lawn to hide all of your cables, is an absolute godsend. The lights are roughly 5.5 by 4 3/4 by 1 1/4 inches, so they're small, but the amount of light that they put out is more than enough for our haunt. Plus the cord between the lights is 10 feet. They have an all-metal housing and are able to withstand whatever kinds of weather you may have during haunt season. So goodbye to the rat's nest of extension cords that used to power all of our floodlights. Let's get to setting these up. With all the lights in place, and a consultation from Mrs. Van Oaks on the location of tombstones, it's time to get to securing them in place with a mallet and some rebar. I made a video on this process, and I'll leave a link to it in the video description if you want to check it out. Off camera, I ran a single extension cord to the lights and powered them up as the sun started to set. The lights have a nice diffusion panel to keep them from hot spotting, which is nice, but I'll have to wait until dark to really see how they work. With the sun finally down, I'm happy to report that these lights work just as expected. The color saturation is good, and the app controls are responsive and were pretty straightforward once I got the hang of things. More than anything, the fact that it took me under 5 minutes to get these set up makes them well worth it. It was at this point that I called it a night, but there was still a bit of setup to finish, mainly the addition of our candles. So the following day I ran all of the cords for those, and the added motivated lighting that's on a flicker module to help sell the effect. There's still a few other odds and ends, but at this point, it's just a lot of tinkering to get everything looking just how we like. But I won't subject you to that. So for now, I'm calling this good. If you're looking to create more interesting lighting effects for your haunt, but you're not ready to take the leap into high-tech prop controllers, stick around. In this video, I'm going to show you a low-tech way to create moody Halloween lighting. To get started, we'll need a few pieces of lumber, a low RPM motor, a light socket assembly, and a deli container. I pre-cut the lumber that will make up our frame, one piece at 10 inches and two pieces at 5 inches, and I'm going to drill some pocket holes with my Kreg jig for easy assembly. You could also use a standard butt joint for this. I'm also going to drill 2 holes for our wires to pass through. Now that we've got the drilling done, we're going to set aside the frame and wire up our light socket. If you saw our electric lantern video, this step will be familiar to you. I'm going to take a small length of wire, strip off about a ½ inch of the sheathing on both ends, and we'll connect one end to the screw terminals on the socket assembly and set it aside. Next up, we're going to take one of our 5-inch pieces of wood and attach our low RPM synchronous motor. You want to align the motor shaft with the center of the piece of wood about an inch in from the front edge. Once you've determined the position, take 2 screws and mount it in place. Now grab the second 5-inch piece of wood and we're going to determine the location for the lamp socket. I like to mock assemble my frame to help figure out this alignment. When I'm happy with the location, I'll mount the socket to the wood. With our frame pieces done, we can focus on the deli container. This container will be the element of the build that will create the variation in our lighting. I'm going to start by applying these cloud-shaped stencils around the container. This could be done in a variety of ways, most easily with painter's tape. The actual shape isn't as important as the spacing, since they won't appear as hard-edged silhouettes, but more so as just changing in the brightness of light. You'll want to create 3 cloud shapes, about 4½ inches wide, and space them around the container. 1 high, 1 in the middle, and 1 low, being sure not to overlap them. Next, we'll create a mounting hole in our container. I'm going to heat up the end of an awl and slowly create a small hole in the bottom of the container. This will be where we mount it to our motor. With the hole made in our container, we can start painting. Give it 2 solid coats of paint to ensure good coverage. I like to use 2 different colors of spray paint to help ensure that I haven't missed any spots. When the paint is dry, it's time to peel off our cloud shapes. If your cloud shapes don't come off cleanly, like they haven't for me, don't worry about it. Because you won't see a sharp edge on these shapes, no one will ever know. Now we have all of our parts ready and we can start final assembly. Take your container and with a small screw, lock washer, and standard washer, attach it to the motor. Both washers should be on the inside of the container. Next, screw in a light bulb to your socket and attach the pieces of the frame together. The last part of the build is adding an extension cord to power our light and motor. Start by feeding the wire leads from the motor and light socket through the 2 small holes we created. Then take the extension cord, clip off the female end, and strip off about a ½ inch of sheathing, and with 2 wire nuts I'm going to connect the motor and light socket to the extension cord. For some added strain relief, I like to attach a zip tie to prevent the connections from coming loose. The last thing to do is to test it out. This effect, while simple in nature, creates a unique movement to your lighting. The speed of your motor will determine the subtlety of the effect. A slower motor will be less noticeable, but create a more interesting atmosphere, while a faster motor will be more eye-catching. Hey guys, welcome back to another tutorial. Today we're going to be building a modified version of our LED spotlights using these outdoor rated Eagle Eye lights that I found on Amazon and some irrigation pipe from my local hardware store. First things first, we're going to drill a small hole in the back portion of the pipe fitting for our mounting hardware. This hole should be big enough to fit a number 8 32nd screw. Once we've got the hole drilled, we can install the rest of the mounting hardware. A 1½ inch L bracket, a number 8 32nd screw, a wing nut, and a lock washer. From here, we're going to install the LED. The light should slide into the pipe and rest on the lip inside of the pipe fitting. After it's properly seated inside the pipe, I like to apply some super glue to keep it in place. These lights are a tight fit, so you may need to sand either the pipe or the light to get a good snug fit. After that, we're going to use some wire strippers to expose the inner wires, and we'll strip off the sheathing. Small gauge wires don't typically do well in wire strippers, so I like to use a lighter to melt the sheathing and then strip it away with my fingers to expose the bare wire. If you've seen my other videos, you know I'm a fan of these RCA connectors, so I'm going to use them once again for these lights. The red wire goes to the small tab, which connects to the center pin, and the black wire to the longer tab, which connects to the outer ring. If you have any unsoldered wire, cut them off with a pair of nippers like I'm doing here. It's always important to have tidy solder joints to prevent the lights from shorting out. Screw the cover back on and we're ready for paint. These lights are a great option because they're watertight and come pre-diffused so there's no hot spotting. They're also really small and will virtually disappear in most haunt settings. Now, every Halloween there's typically something in our display that I want to change or upgrade, and oftentimes that comes with an opportunity to learn something new. So in this video I'm going to do both, by upgrading one of our lanterns using an Arduino and a NeoPixel ring. So let's get to it. Before we get into the build, let's take a look at how we'll need to wire up our Arduino controller for this project. There's 3 key points on the board that we'll need: the D6 data pin, the ground pin that is on the same side as the data pin, and lastly the 5-volt out pin. These will all connect to the NeoPixel ring light that will be creating the improved flicker for my lantern. With that out of the way, let's get down to soldering. The first thing you'll want to do after stripping off a bit of the outer covering off your wires is to tin them with a bit of solder. This will help to ensure a solid connection between the wire and the board. I'm also going to add a bit of solder to the terminal on the back of the NeoPixel ring for the same exact reason. Once that's taken care of, I can solder the wires to the data, ground, and power terminals on the back of the ring by simply pressing the wire to the ring's terminal using the tip of my soldering iron, which should reactivate the solder I just applied, and as soon as I remove the iron, we'll join the two together. With my LEDs wired up, I can switch my attention to the Arduino controller and soldering my connections to the correct pins. With the red wire going to D6, the white wire to ground, and the green wire to 5V out. These colors aren't necessarily important, but what is important is keeping track of what wires go where. My connections to the board were a little sloppy, so I'll use some nippers to remove any stray wires or unneeded solder from the board. Now that the brains of this build are taken care of, I can shift to the actual lantern. As you can see, it's a little worse for wear, which I like, but it only has a single flicker LED bulb, and that's just not getting the job done. So I'm going to remove the globe to expose the inside of the lantern and see what my options are for mounting this ring light. But first I need to get this LED out of here. I was hoping that the opening for the wick would be wide enough to pass the Arduino through, but it wasn't. So I'll need to undo my solder joints. Once that was done, I could run the wire through the body of the lantern and out the wick opening, and solder the connections again before I go any further. With that out of the way, and a quick test fit, I heat up my glue gun and apply a bit of hot glue to the wire terminals to prevent any shorting as a result of it coming into contact with any of the metal on the lantern. I'll also apply hot glue along the NeoPixel ring, both to hold it in position and also to protect the connections from the elements and the lantern. This shouldn't dim the LEDs, but in the event that it does, I can control it from within the Arduino code. And speaking of code, let's take a quick look at it. Now I should mention that I am not handy with writing code and have a very basic understanding of wiring, but if I'm doing this project, so can you. That said, I found this code online and was able to modify it slightly to get the candle flicker just how I wanted, starting by selecting the data pin and the number of LEDs on my NeoPixel ring. The brightness was already set to 50, but you can adjust this number higher or lower to match your needs. For now, I'll leave it as it is. The next thing I adjusted was the color of the LEDs. This program works in 4 sets of 3 lights each for a total of 12 LEDs. Each set of 3 has 1 red light and 2 different shades of yellow, and they randomize their individual brightness to create the flame look. I tried quite a few variations and found that these 3 looked the most like the colors in an actual candle flame. So if you're shooting for replicating a real candle, you won't need to change this. The last thing of note is the delay. This adjusts from 10 to 50 and controls the speed of the flicker, with lower numbers creating a fast flicker and high numbers a slow one. With the basics covered, you can adjust any or all of these options to dial in the perfect settings for your project. But for this build, this is the code I'm using, which I've uploaded to my Arduino using the USB port. With the code out of the way and the hot glue still cooling, I'm going to redo the frosting on the lantern's globe. But first I'll need to wipe off the old frosting with a bit of isopropyl alcohol. Once the glass was relatively clean, I could apply some of this frost effect paint with a sponge to minimize streaks in the finish. I'll coat the globe, allow it to dry, and repeat until it's got nice even coverage. This frosting should hide any of the bright spots from the individual LEDs and will give it a nice warm glow. After the third coat had time to dry, it was ready for a bit of clear coat to help lock it in and prevent it from fading or chipping away too easily. I also decided to add some soot to the bottom edge of the globe with black spray paint, since I had a feeling that the LEDs may still be visible even with the frosted glass. Plus, it'll give it a nice aged look, so it works for both form and function. Now it was time to put the globe back in place. This is always a bit of a pain and will inevitably scratch the frosting, but I should be able to touch it up if necessary. The final part of this project is to enclose the Arduino, so I 3D modeled and printed a small box for it, but you could just as easily use a food storage container or some other small box to help protect it from the elements. The only thing left to do now was power it up and see what we've got.
Now, as a maker and Halloween fanatic, I'm always looking for ways to improve on props I've made in the past, either by streamlining the process or by introducing new materials to help improve an existing design. So in this video, I'm actually going to do both, as I revisit a classic, PVC Halloween candles. So let's get to it.
So first things first, and probably the biggest change to this build is the pipe. This is Schedule 30 PVC pipe, which is also sometimes called sewer and drain pipe. Its walls are about half as thick as Schedule 40 PVC, which means that it will allow for light to pass through it and give that warm candle glow. As an added bonus, it's also a lot easier to cut by hand if you don't have access to a powered saw. And before I get started on any PVC project, I need to remove the writing on the side of the pipe, and I'll do that with a bit of acetone. Now that I've got that out of the way, I want to start shaping the pipe so that it's a bit less industrial and a lot more organic. So I'll roughly sketch out a guideline around the top edge of the pipe, and we'll sand it down with a small sanding drum and my rotary tool. This line doesn't have to be perfect. As a matter of fact, you don't have to draw the line at all and can freehand the shape. This pipe is pretty forgiving and sands quite easily, so even if you make a mistake, it'll be easy to fix. Any edges that are a little rough can get smoothed out with the rotary tool or with a piece of sandpaper. And if you have any of your marker lines still visible, just grab some isopropyl alcohol and wipe it away. With the pipe shaped, cleaned, and dusted off, we can get down to the fake wax strips. And for that I'll be using these white hot glue sticks and my tiny glue gun. When applying the drips, I like to start from the bottom of the drip and work my way to the top of the pipe. This gives more of a natural look because the start of a bead of hot glue has a more rounded look to it. This also helps to minimize the amount of stringing that can happen as you pull the hot glue gun away from the pipe, and instead puts it over the top of the candle lip where it can more easily be dealt with. Using the white glue sticks for this build is a big plus, especially after tracking down this thinner pipe. The last thing we'd want to do is make it more difficult for the light to pass through it by applying a coat of paint to the entire candle. What I think helps give these candles the right look is to build up the drips on top of themselves after the glue has started to cool. Filling in the spaces in between drips and working up and over existing ones gives it a bit more bulk towards the top. To give the candle even more bulk, I like to run a bead of hot glue along the cut edge, which helps to cover up any exposed pipe. Now it's time to deal with the stringing, but first I'm going to need my heat gun. The heat gun is a great way to help blend your drips together and make them look more natural. Additionally, any of the really fine strings of glue will kind of disappear when introduced to the heat, and the remaining larger ones will get absorbed back into the rest of the glue. I'm essentially melting the hot glue for a second time, but not heating it enough to melt the pipe. When I'm happy with how everything is melted together and the glue is completely cooled, I'll grab some wax paint and we'll use it to age the candle a bit. It's a simple brush on and wipe off method, and you can work the paint as much or as little as you like until you get the desired effect. I tend to focus on darkening the drip areas, which should help them to stand out better at night, and will wipe away most of the paint from the pipe, leaving behind a subtle tint to give it an aged look that doesn't prevent the light from passing through. This wax paint likes to pool in the recesses, so after I've wiped away most of it, I'll go back with a dry brush and will soften the appearance so that the paint isn't too severe. I also like to drag down from the drips toward the bottom of the pipe to give it a bit more visual interest. And don't forget to paint the inside areas that may be seen when it's on display. With the paint out of the way, it's time to add some lights. But before I do that, I want to make a small notch on the back side of the candle that I can use to pass any wires through and still have the candle sit flat. So I'll draw a guide for myself, and off camera I'll use my rotary tool to remove the section of pipe. Now we can get on to the lights. And for this I'm going with a much more simple approach than I've used in the past, by using two 12-volt flickering LED bulbs. You can buy these online pre-wired to save you the trouble of having to select the right resistor, and because they run off 12-volt power, they'll work with my low-voltage plug-and-play lighting box. I'll leave a link in the video description if you'd like to check it out and build one for yourself. I'm going to hot glue the two LEDs in place near the bottom of the pipe, and then I'll grab a small piece of this packing material and we'll glue that over the bulbs to help diffuse the light. This will give it a much more pleasing glow and will help to minimize hot spotting that happens with LED bulbs. And once the sun has started to set, it's time to test it out. As you can see, the glow from the LEDs can be seen faintly through the PVC pipe, which I think looks more like a candle that's been hollowed out after multiple uses. And the added paint helps to give the drips more shape and bring some much needed character to our candle.
A question I get asked pretty regularly is, how do I improve the lighting in my haunt? And while there's no simple answer to this question, I can tip you off to something I've been a bit obsessed with for the past few years, which are lighting gobos. Now, gobo is essentially putting a silhouette of some kind in front of a light source to create texture or patterns. And while the professional models are usually pretty expensive, I think I may have come up with a solution that fits most budgets. Let me show you what I mean.
Over the years, I've been trying to come up with a DIY approach to these lighting gobos or go-betweens. They're essentially a cutout of a shape or a silhouette that when placed in the path of a light source can create that added bit of interest to your lighting. Here's a few examples. You can see how they bring so much more interest and texture to each of the scenes, just by putting a design in front of a light. Usually they're placed in front of high-powered spotlights, but what if you're like me and only use smaller LED bulbs like this one? It's an idea that's been bouncing around in my head for a few years. And so I hopped into my 3D modeling software and came up with these two parts. They're basically a pair of caps. One cap that allows for the use of a professionally made or DIY poster board gobo, and a second cap to mount an LED light, that when paired with a piece of plumbing pipe, create a DIY gobo. Since most of us won't have the larger steel cut style gobos, I also modeled a version that's half the size so it'll fit in tighter spaces, takes these Eagle Eye LED bulbs I found on Amazon, and uses a 2-inch PVC pipe coupling. And with a piece of poster board, you can create your own insert to meet whatever your lighting needs are. If you need to mount these, you can simply drill a hole in the side to accommodate some hardware and create a ground stake by heating a piece of PVC pipe, pinching the end into a flat surface, and drilling a matching hole through the flat end to attach the gobo housing. I'm holding it all together temporarily with a bit of gaffer's tape to make sure that everything fits, and eventually I'll seal it together with a bit of CA glue or 5-minute epoxy. But for now, let's see how it works. Sadly, my camera doesn't do well in low light situations, but you can see how much more interesting the light is as it goes from the solid amber color to the textured light created by the gobo.
I was recently wondering whether or not it was possible to recreate these old lightning effects boxes that were pretty popular when I first started haunting, but they're not available anymore. And the options for creating lightning effects that are on the market today are pretty expensive. So I did a deep dive into Amazon and I found some technology that I think just might fit the bill and is pretty affordable. So let's see if it works.
I stumbled across this $20 DIY light organ kit. I knew I'd have to assemble it and that would require some soldering, but I figured for the price and how I was planning on modifying it, this might be a good solution. So after I checked to make sure that all of the components were accounted for, and a quick look at the instructions, it was time to start assembly. If you're considering tackling this project, fair warning, there is a bit of soldering. Now I won't force you to watch me do the entire thing, just know that you'll need to have a bit of patience, but your patience will be rewarded. If soldering isn't your thing, don't worry. They also sell completely assembled versions to save you time. You'll just need to do a bit of modification to one part, but I'll cover that in a moment. Now, even though I've used this kit once before, I refreshed my memory with a quick review of the instructions and set off to solder all of the components. Okay, maybe I lied. This is all the soldering, but at least it's a time lapse. If the concept of soldering seems a little overwhelming, just remember, if I can do it with 9 fingers, you can do it with 10. The biggest question I had for this project was whether or not I could substitute an RCA connection where the small microphone is supposed to go. So once I finished soldering all the resistors in place, it was time to make a short RCA cable and wire it to the board. And with the RCA cable installed, it was time to add power. To make it easy, I'm just using a few inches of wire and attaching a barrel connector. I'll do the same for the output, which is where I'll connect the light. The next thing to do was to put the light organ into some kind of project box for protection. I had this one on hand that was a close enough fit, but needed a little modification. So I cut an opening into the top to accommodate the light organ and sanded a notch on the side to allow the connections to exit the box. And with everything in place, it was time to wire it up and test my theory. Connected the RCA cable from the light organ to one side of the stereo outputs from this small amplifier. The other stereo output is connected to a speaker. Then I connected the light organ's output to the floodlight using some barrel connectors. I found this small, cool white LED floodlight that will work with the 12-volt power output of the light organ. Now you'll notice I said cool white, which is in reference to the lamp's color temperature. Color temperature is not an indicator of the heat output of a bulb, but rather it lets us know what the look and feel of a light will be using warm and cool colors. Here's a great reference scale to give it a bit more context. In this case, I've chosen a floodlight with a color temperature of 6500 Kelvin, or sometimes listed as 6500 K, and it puts off a bluish tint similar to the bluish-purple tint of lightning. These numbers are helpful when trying to choose the best light for your scene. So just remember, the higher the number, the cooler the light will look. The lower the number, the warmer it'll look. Last thing to do was to plug it into the 12-volt power supply, add some thunder sound effects to the amplifier, power it on, and see if it works. Theory confirmed. Sort of. There's a caveat to this build. While there's a sensitivity knob on the light organ, it's not very effective since the light organ is designed to work with a small microphone, and not a line audio input. It may work even better if there's a potentiometer added between the amplifier and the light organ module to lower the audio to a volume that the module can handle, which should, in theory, make the sensitivity knob work more effectively. Aside from that, I'd say this is a pretty great solution.
Well, that looks like a lightning effects box to me. Now I know this project had its fair share of soldering and that might turn some people off, but I think if you give yourself a chance, you may find that soldering is not quite as difficult as you thought. That's going to do it for this video. Be sure to like and subscribe if you haven't already, but most importantly, go make something.